What's the biggest planet in the universe? What's the biggest thing or structure in the universe? It's a question that has captivated humanity for millennia, a query that pushes the boundaries of comprehension. Get ready to have your mind blown as we count down the 10 largest known things ever discovered, from massive planets to structures that stretch across billions of light years. We'll venture far beyond our familiar solar system to the edges of the observable universe, encountering objects so huge they defy intuition, and learning how we measured them. My name is Michael Hepner, aka The Matrix. I've gazed up with wonder since childhood, and today we begin a grand tour of cosmic titans. We won't just list them, we'll show how they were discovered, why they're so colossal, and why they challenge our models, from the merely gigantic to the incomprehensibly vast. Settle in as we start at number 10. So, what do you think? I would love to hear from you in the comments below. In Ophiuchus, approximately 460 light-years away, a true giant orbits. ROXs, 42 BB. It blurs the line between planet and star, approximately 9 times Jupiter's mass, roughly 2.5 times Jupiter's diameter. Think over 3,000 Earths in volume. Methodology. Direct imaging at Keck separated the planet's faint glow from its stars, a firefly beside a searchlight. Its orbit sits hundreds of AU, far beyond Earth-Sun distance. Models struggle. Core accretion is too slow, that far out. Disk instability makes objects even larger. It likely glows from residual formation heat, a turbulent atmosphere under immense pressure. Why top 10? Among the largest directly imaged exoplanets, by size and mass, it challenges planet formation theory. And this is just a planet. Next, stars so vast, they'd engulf our inner solar system. In our neighboring LMC, Large Magellanic Cloud, resides WOH G64, a titanic red supergiant. Estimates exceed 1,500 times the Sun's radius. Its surface would reach beyond Jupiter's orbit. Methodology. Interferometry resolved its disk, measured angular diameter, distance, then physical size. A thick, light-year-scale dusty torus, a donut-shaped ring of gas and dust surrounding a supermassive black hole at the center of an active galaxy, obscures it, complicating precision. It's shedding outer layers that will seed new stars and planets. It will end in a brilliant supernova, leaving a neutron star or black hole. Why top 10? One of the largest resolved stellar radii, empirically measured despite dust. A genuine colossus, if that seemed large. The next star once wore the crown. In Scutum, Scuti, a red supergiant and pulsating variable. Its radius approaches 1,700 suns. Its brightness waxes and wanes over about 740 days. In contrast, circle the Sun in months. Scuti would take centuries. It could enclose nearly 5 billion suns by volume. Methodology. Gaia, distance, plus brightness and temperature, feeds stellar physics to compute radius. Furious mass loss and pulsations signal a looming core collapse supernova. Why top 10? Historically among the largest measured stars, with clear variability and robust distance constraints. Next, a hypergiant wrapped in chaos. Stephenson 218. A red hypergiant, located in the Stephenson 2 star cluster in the constellation Scutum, approximately 19,000 light-years from Earth. It is one of the largest stars known, with an estimated radius around 2,100, 50 times that of the Sun. Methodology. Astronomers use the Australia Telescope Compact Array, ATCA, for subsequent observations, including a 2012 study of maester emissions from red supergiants across the galaxy. Data from the Spitzer Space Telescope has also been used to study its infrared output. The star's estimated radius is so large that if it were at the center of our solar system, its surface would extend past the orbit of Saturn. The star is in the final stages of its life and is described as a very late type red supergiant. It is likely on the verge of shedding its outer layers before eventually exploding as a supernova. Why top 10? Hypergiant scale plus direct constraints through cutting-edge imaging makes it a definitive behemoth. We now leap to galaxies. Leviathans of a different order. A2261 BCG, a supergiant elliptical and brightest cluster galaxy, over 544,620 light-years across, among the largest known. Methodology. Bulge scaling implies a black hole of about 10 billion suns. But Hubble and Chandra saw no central bright source. A strangely large, diffuse core. Hypothesis. Two SMBHEs, supermassive black holes, merged, and a gravitational wave kick launched the remnant out of the core. Why top 10? Immense size plus a rare potential supermassive black hole recoil. A giant wrapped in a mystery. Next, another Leviathan of galactic proportions. IC 1101, a supergiant elliptical at the heart of Able 2029. It spans about 553,000 light-years, could engulf Andromeda, and more. Methodology. Deep surveys and surface photometry map a vast, diffuse stellar halo. Key to its true size, it grew by cannibalizing smaller galaxies over eons. Why top 10? One of the largest known galaxies by extent and halo, a monument to gravity's relentless work. Onward to another ghostly giant, ESO 38376, a supergiant elliptical dominating its cluster. Its ghostly halo stretches to about 1.7 million light-years. Methodology. Long exposures and careful subtraction trace ultra-faint outskirts, photon counting at the limits. It grew by absorbing countless smaller galaxies. Their stars now populate its diffuse halo. Why top 10? Enormous measured halo size and a clear forensic record of galactic cannibalism. From the biggest somethings to the biggest nothing. The Eridanus Supervoid, a colossal under density, about 1.8 billion light-years across. Yes, billion with a B, not a vacuum, just far fewer galaxies, gas, and dark matter than average. Methodology, a cold spot in the CMB, cosmic microwave background, suggested photons, lost energy, crossing a vast void. Deep redshift surveys built a 3D map, confirming a massive, underdense region aligned with the cold spot. Why top 10? One of the largest mapped cosmic structures, defined by its profound emptiness. Now, a mysterious ring traced by the universe's brightest explosions. The giant GRB ring, 9 gamma-ray bursts outlining a near-perfect circle. Implied diameter, about 5.6 billion light-years. Methodology. Satellite detections mapped to a similar redshift, hinting at a coherent large-scale feature. At about 1/20th of the observable universe, it challenges the cosmological principles' size expectations. Many remain skeptical. It could be a projection or statistical fluke. Why? Top 10. If real, it's among the largest organized patterns ever inferred, and deeply controversial. Number 1. A structure so vast, its name must be epic. The Hercules Corona Borealis Great Wall. Not stone, but a filamentary supercluster complex bound by gravity. Methodology. A concentration of GRBs, gamma-ray bursts, at similar distances, mapped a dense sheet spanning the sky. Its length is about 10 billion light-years. Light needs 10 billion years to cross it. Just think about that for a moment. It dwarfs the theoretical homogeneity scale. Our models strain to explain it. Why? Top 10. The largest known structure on the cosmic map. The grandest feature of the observable universe. From a world that dwarfs Jupiter to a wall spanning a tenth of the known universe, we've reached the limits of scale. Each titan inspires awe and challenges the foundations of cosmology. With bigger telescopes and smarter techniques, new giants will emerge. Ready to dive deeper into the matrix? Watch the next video here to see just how deep the rabbit hole goes. If you enjoyed this journey, like and subscribe, and tell us which behemoth blew your mind. We used real imagery wherever possible from the reference sources, because accuracy matters at this scale. There's a whole universe waiting to be explored. Until next time, keep looking up.